Good evening, class. We are looking at Chapter 2, Equations and Inequalities for College Algebra. Here, Section 2.2, Linear Equations in One Variable. Linear Equations in One Variable. Section 2.2. So we covered 2.1, the rectangular coordinate systems and graphs, and now we're going to go look at linear equations in one variable. So the objectives is to solve equations in one variable algebraically, solve rational equations, find a linear equation. Given the equation of two lines, determine whether their graphs are parallel or perpendicular. Write the equation of a line parallel or perpendicular to a given line. By the way, all of this stuff we have seen in previous courses, just a reminder. This is a rectangular coordinate system, also known as a Cartesian coordinate system. We cut it into 4 parts known as quadrants. Obviously, in the first quadrant, everything is positive, x and y. Second one, x is negative. Third one, both of them are negative. And fourth one, only y is negative. We have the distance formula following Pythagorean theorem. B is square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. And the midpoint, you simply add up the x coordinates divided by 2, add up the y coordinates divided by 2. Solving linear equations. Let's see how we do that. A linear equation in one variable is an equation written in the form of ax plus b equals c, where a, b, and c are real numbers, and a is the one that can't be 0 because then you don't have any x to solve for. So for example, 3x plus 5 is 25 minus 5x. Okay. Any value of a variable that results in a true statement is called a solution of the equation. Example 1. Determine if x equals -1 is a solution to the equation. What equation? -3 times x minus 3 equals -4x plus 3 minus 5x. Replace the x here, here, and here with -1. And -1 and -3 is -4. Minus 4 times -1 is +1. This remains as 3. This is +5 because -5 times -1. And as you can see, the product of these two on the left side is 12, and 4 plus 3 plus 5 is also 12. Because this is a true statement, yes, this is a solution. Solve this equation. Of course, even if they don't say it, we have to use the distributive property, which means we are going to distribute number 3. So this remains the same, 12 minus 2x, minus 3x minus 6, then 4x plus 12 minus x. On the right side, class, we can put this into 3x. On the left side, number 12, number -6, they add up to +6. These two add up to -5x. We move the 3x to the left, becomes minus 3x. We move the 6 to the right, becomes -6. You can do it in one shot. Combining these two results in -8, 6, and these two in +6. Now you are going to divide both sides by -8. So -6/8 or -3/4. That would be the final answer. 2x plus 9 equals 14. All you have to do, move the 9, becomes negative 9, with 14 becomes 5, divide by 2, we're done. A couple of ways to do that. You can move the 5 and then multiply both sides by the reciprocal of negative 2/3 or negative 3/2. Or generally speaking, when we deal with fractions, it's really a good practice to get rid of the denominator. So all you have to do, multiply both sides by this denominator 3. So when you do that, this gives you 3 times 5, which is 15. This gives you 3 times minus 2a over 3. The 3's cancel out. And the right side is negative 27. So most of the time, I won't write this step because it's redundant. And so I'm going to move. So basically, I would say 3 times 5 is 15. 3 cancels out the 3 minus 2a. And this is minus 27. I'm going to move the 15. Becomes negative on the other side. With negative 27, they add up to negative 42. We divide by negative 2. We want to solve this equation. 2 over 5 plus v is 1/2 minus 3 over 10. Fractions can be removed by multiplying both sides of the equation by the least common denominator, LCD, of all fractions. No matter how many fractions you have 1, 2, 3, and I hope you recognize the LCD is 10 for all those fractions. If I multiply both sides by 10, every fraction will lose its denominator. So I'm going to multiply the 10 by 2 over 5 by v. I'm going to multiply 10 by 1/2 minus 10 times 3 over 10. Now, normally, again, I'm going to skip that and go to the next step. But just to show you, this one cancels out this one. You get 2 times 2 is 4. Okay. This one cancels out this one. You get 5. This one cancels out this one. You get negative 3. And obviously, this is 2. Move the 4, subtract it from 2, you get negative 2. Divide by 10, and you get negative 2 over 10 equals negative 1 over 5. I'm going to move on. I'm going to leave this for you to do it on your own. Make a note of it. All you have to do, multiply by LCD both sides, and I hope you recognize for 9, 2, and 6. The least common denominator would be 18. So here's my tip. Multiply both sides by 18. Do the math. A rational equation is an equation that contains one rational expression or more. That's the definition of a rational equation. To solve rational equations, as it was discussed, find the LCD of all rational expressions, in this case, or fractional expressions or fractions. The denominators are 6, 4, and 8. And I hope you recognize that you have to multiply by LCD, and the LCD is 24. Now, in case you want to know why it's 24, I'm going to quickly remind you of what we learned in basic math. Number 6 If you factor it, it's 2 times 3. Number 4 is 2 squared. Number 8 is 2 cubed. So the least common multiple, and now it becomes the LCD, is 2 cubed times 3, which is 24. All right, when we do that, this goes away, this becomes 4. For this one, when you multiply by this, 24 cancels out the 4, and you get 6x. When you multiply it by this one, 24 cancels out the 8, and you get minus 3 times 3. And so that's what we get. We are going to move the 6x to the left, and with 4x becomes negative 2x, because we are going to combine like terms on each side of the equation. And there's nothing to combine, so we move things around. Solve and check. So minus 2x is negative 9. Divide by negative 2. X is positive 9 halves. And you really should check. Checking takes place with the original equation. I leave it for you to check it. Make sure you check that, everybody. Three over x plus 3 equals 5. A couple of different ways of handling it. One would be just to multiply both sides by LCD, namely x plus 3. Needless to say, x can't be negative 3. Let me explain this concept. First of all, x plus 3 is the denominator. You multiply both sides by it. Why is it that x can't be negative 3? Anytime you have a variable in the denominator, if it's a number, you have nothing to worry about. If it's a variable involved, in this case, x plus 3, can x plus 3 be 0? If you set equal to 0, becomes negative 3, and the answer is no, therefore x cannot be negative 3, meaning you go through the process. If for any reason you end up with negative 3 as the answer, then that's not an acceptable answer. It's called extraneous solutions. So when you multiply this by the left side, becomes just 3, by the right side becomes 5 times x plus 3, which is 5x plus 15. You move the 15, becomes negative, and so you have negative 12 equals 5x. Divide both sides by 5, and x becomes negative 12 over 5 as the final answer, everybody. We want to solve this equation. As you can see, it's a rational function. You look at the denominators are 4, 2, 4, and therefore 4 is the LCD. You multiply both sides by 4. When you multiply this one by 4, this goes away and becomes 3x. When you multiply 4 by 1/2, you get 2. When you multiply this by 4, this goes away. So the right side is very clear. You're going to move things around as follows. You're going to subtract the 2x, and then you move the 2, and you get that. Okay. So x equals negative 5. As always, you can check with the original equation. there is no variable here in the denominator, as you can see. If there is a variable in any denominator, exclude any value that makes any of them 0, since division by 0 is undefined. Any value that makes a denominator 0 is not a solution, and it's called an extraneous solution. So, for example, this one, we should exclude 0 because the first one, x can't be 0. The second one gives you the same answer. Now we're going to multiply both sides by LCD, and I hope you recognize the LCD is, okay, the denominator is x, the denominator is x, the denominator is 4 here, therefore LCD is 4x. So what happens when we multiply this by 4x, 4x cancels out the x, you get 2 times, you get 4 times 2, 8. 4x cancels out the x, you get 4 times 5, 20. 4x cancels out the 4, and x times -1 gives you minus x. So I hope you can go from here to here. One more time. This x cancels out this x, you get 4 times 2 is 8. This x cancels out this x, you get 4 times 5, 20. And for the second one, for this one, the 4 cancels out, the x remains, times -1. And obviously, minus x is -12, x is positive 12. And you should check with what you wrote here. X can't be 0, so we are in good shape because x is a number that is not 0. All right, we want to solve this, and first and foremost, we are going to multiply by the LCD, which is the product of 3x plus 1 and x. That's how you find this, because there's nothing in common, and this is being repeated. Also, according to this one, x can't be -1/3. According to this one, x can't be 0. I hope everybody can see why. Again, the LCD is the product of these two, so we're going to multiply both sides by that. X can't be 0 here, x can't be -1/3 here and here. So the left side, we just lose the 3x plus 1, and it becomes 2x, and you're done with the left side. What happens if I want to multiply it by this? Just the first one. I hope you recognize the x goes away, and we get 3x plus 1 times 1, or simply 3x plus 1. So this will give us 3x plus 1 times 1. When you multiply it by this guy, 3x plus 1 goes away, you get x times 6x, and don't forget the negative sign. Okay? To solve this, we're going to bring it to the same side as follows. First, because this is -6x squared class, let's just write it down. Okay, we are going to move everything this way, so we get 6x squared plus 2x. This becomes -3x. This becomes -1. And the reason I'm bringing it on this side, because I want the leading term have a positive leading coefficient. 2x and -3x will add up to -x. This is simple factoring. We discuss the factoring with more details later on, but you should be able to handle this because this is 1, okay? So the way you do that, open up a couple of parentheses. As you know, 6 can be 3 times 2 or 1 times 6. And -1, you have no choice to go with 1 and 1. One of them negative. So it's a good practice to start with this. And when you do that, if you go with 3x here, 2x here, then you just decide, do I put the 1 here or negative 1 here? Do I put the 1 here or negative 1 here? And it's a trial and error. Notice what should work is the middle term. This works out to 2x. This works out to minus 3x. And the sum should be minus x, and it is. Again, we will go over that with more details later on, although you have seen factoring before. So 3x plus 1 is 0. That means x is negative 1/3. 2x minus 1 is 0. That means x equals 1/2. Now we go back. We notice over here we wrote x can't be 0, so we are in good shape. And then x can't be negative 1/3. We are going to get rid of that, which means in the process, somehow this equation has this solution, but the original one doesn't. This is not acceptable for the original equation. It's called an extraneous solution. All right, we want to solve this. Again, it's a rational equation. We have to multiply both sides by LCD, and to do so, we want to make sure every fraction in the denominator has a factored form of that. So this is fine, this is fine. This happened to be the product of these two. I hope you recognize that, because as you recall from basic factoring, we want two numbers. The product is 21, the sum is 10, okay? 21 is the product of 3 and 7. So what is the LCD? Well, it's simply this one in the form of a product. We're going to use it a plus 7 times a plus 3. And also, none of the denominators can be 0. This can't be 0, so a can't be negative 7. This can't be 0, a can't be negative 3. The same thing goes here. You're going to multiply both sides by LCD. And you're going to say it can't be those numbers. We're going to multiply everything by this LCD. And so what happens is, if I multiply this by this guy, okay, I want to make sure everybody understands what's happening here. If I'm just concerned with this one, this cancel each other, and I get a plus, what did I do? I meant to first of all, I need a different color. I meant to say this. So all I need is 2a times a plus 3. So for this part, I get 2a times a plus 3, or a plus 3 times 3. This one simply multiply by this. So that's not a big deal. Let's go to the right side. When you multiply this one by this one, you just get 1, because a plus 7 times a plus 3 cancels out a plus 7 times a plus 3. What happens when you multiply this guy by this guy? A plus 3, let me actually show. A plus 3 cancels out a plus 3. So you get minus a times a plus 7. Oh, this is plus. Let me erase it. This is plus, everybody. I thought it was minus because I went through that. So let's do it again. This times this A plus 3 cancel each other. So we get A plus 7, and then this is plus A times. So this is what. So what happens next? All we have to do, distribute and simplify. First and foremost, we remember that this is the product of these two. So we have the negative sign in front of that. Okay, same thing, we write it here because it was a product, and don't forget there's a negative sign. If I distribute the 2a, I get 2a squared plus 6a. This one, I get the same thing, everything changes sign, minus a squared, minus 10a, minus 21. The right side, 1 plus a squared plus 7a. So let's put the right side in descending order, a squared plus 7a plus 1. Let's combine like terms on the left side. These two add up to a squared. These two add up to negative 4a. Everything else remains unchanged. We can drop the a squared from both sides just because they're identical. You don't have to move it. They're identical. You don't have to move them, drop it. They are identical on both sides of the equation. I'm going to move this. We make it minus 7a with minus 4a is negative 11a. Then I move this minus 21 becomes plus 21 with 1 becomes 22. Divide by negative 11. A is minus 2. Check. All is fine. Needless to say, it's a good practice to check with the original equation. Proportions. A proportion is an equation of the form A over B equals C over D, where the denominators B and D can't be 0. So here's an example of a proportion. Also, proportions may also be solved by cross multiplication as follows. If this is a true proportion, then their cross product must be identical. So AD must be equal to BC. So it's the same as multiplying both sides by LCD, but just basically do the cross product. So 2 times 2x plus 3 is 5 times 3x minus 1. And again, this goes for these two denominators. They cannot be 0. 3x minus 1 set it equal to 0 becomes 1/3 excluded. 2x plus 3 set equal to 0. Negative 3/2 excluded. When I say excluded, it means not equal to. Distribute, we get 4x plus 6. Distribute, we get 15x minus 5. We are going to move things as follows. But this is 11x. This is 11. X becomes 1. Pretty straightforward, everybody. The slope, as you recall, it's known as rise over run. Delta y over delta x, or y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So here's the change in y known as the rise, y sub 2 minus 1, y sub 1, as you go from one point to the next, as you go from P to Q. And here's the run or change in x. So that's the definition of a slope. which means in application, the average rate of change of y with respect to x. That's the slope. That is the slope, everybody. That's the meaning of the slope, everybody. Now, when you look at this example, the slope is undefined because rise over run, there is no run, and you can pick up 2 points. If you put this into this equation, you see the denominator becomes 0, and therefore for any vertical line, the slope is undefined class. If we want to find the slope of this line containing the following points, we just follow the equation here, y sub 2 minus 3 minus y sub 1, 4, over x sub 2 minus x sub 1, 2 minus negative 1, which makes it 2 plus 1. The top is negative 7, the bottom is 3, and it's minus 7/3 as the final answer. Okay, everyone, does that make sense? All right, for the following lines, L1 having those points, L sub 2, L sub 3, L sub 4, graph all 4 lines on the same set of coordinate axis. I just want to show you something in regards to this question, which is really important. You can calculate those slopes easily. Use this formula and you calculate them and you're done. It's a very simple case. I don't believe anybody has any problem with it. Now, the point I want to make here would be the following graphs. Positive slope, negative slope, slope that is undefined, slope that is 0. For a vertical line, undefined. For a horizontal line, 0. When the slope of a line is positive, the line slants upward from left to right. In other words, I will write that in a moment. When the slope of a line is negative, the line slants downward from left to right, L sub 2. When the slope is 0, the line is horizontal. When the slope is undefined, the line is vertical. The first one I want to mention, this one means when x gets larger, y gets larger. This one means when x gets larger, y gets smaller. So this has got to do with the negative, and this has got to do with the positive slope. So these are some general ideas I want you to know. We're going to graph the graph lines given a point and a slope. You can always make up 2 points and graph it. I want you to know that. But how does that work? Draw a line that contains this point 3, 2 and has a slope of 3/4. If the slope, remember the meaning of a slope, rise over run. So if you think about this number rise, the change in y over change in x. So you add, for the x, you add the bottom, for the y, you add the top. In other words, if you have 3/4, add 4 to x, the bottom to x, and the top 3 to y. So if I want to add 4 to x, I'm going to add 4 to 3, and I get 7. If I want to add 3 to y, I get 5. So I can see what happens is that from 3, 2, I go 4 to the right, 3 up, gives me the second point, and I graph it. That's the concept. Now, you can think of this if you want. For example, as -3 over -4, which means instead of adding, you're going to subtract 4 to x from x, and you're going to subtract 3 from y, and it results in -1, comma -1. That's another point. Somewhere there. Or you can think of it as 6 over 8, add 8 to x and 6 to y. I mean, there are infinitely many points you can do. When you look at this one, anytime the answer is the slope is negative, you have to decide where to put the negative sign, either at top or at the bottom. You can't keep it in front of a fraction bar if you want to make up a new point. So for example, you can write -4 over 5 or 4 over -5. If you write it in this fashion, now -5 gets added to x, -5 and 3, -2. And 4 gets added to y, that means 6. If instead of that, if I use m equals -4 over 5, now I'm going to add +5 to x, -4 to y, and I get 8, comma -2. That's this point, okay? So given 3, 2, the run is -5, so go to the left, and the rise is 4, go up. That gives you the new point. Or you can go the other way around. You make the run positive here and the rise negative. This is in case you want to go with that methodology. All right, we want to graph this. I hope you recognize x equals -2 is simply a vertical line. So this is the x-intercept -2, 0. However, you can pick up a few points. What really matters is the x-intercept, and then you come up with the vertical line. VL, short for vertical line, as the equation x equals a, the slope is undefined, and the x-intercept is located at a0. So in this case, -2, 0. If I said x equals 1 would be this one. Find the equation of a horizontal line containing the point. You don't have to do anything. If the pair is given, horizontal line y equals -4, vertical line x equals 2. In the case of a horizontal line, the equation is y equals b, so y equals -4, the slope is 0, and the y-intercept is located at 0b. Okay, 0b, in this case, 0, -4, this point. So very straightforward. Different forms of line. Everybody remembers the standard form ax plus by equals c. So we want to find the equation of a line with slope of -3, and it contains the point -1, comma 4. So here's the standard form everybody remembers. Here's the slope-intercept form, y equals mx plus b, which means, just for the sake of argument, if you solve this for y. And here's the point slope, y minus y1 equals m times x minus x of 1. So various format. So if we want to stick with that, y minus y1, that means y minus 4 equals m negative 3x minus x of 1, that means x minus minus 1. And that makes this plus 1. You distribute the negative 3. You move the negative 4 becomes positive 4. And here's the equation. You should always put it in slope-intercept form unless asked otherwise. And basically, you can pick up a couple of pairs and graph it if you want. One of the pairs from here, I hope you recognize, it's the y-intercept of 0, 1. But in any event, if you want to go with the methodology that was discussed, we have negative 1 comma 4, and the slope is negative 3. Let me just write that. Okay. As, for example, 3 minus 3 over 1. Okay. You have to put it in a fractional form that it becomes clear. So if you write it as such, then the run is positive 1, the rise is negative 3. That's what they are showing here. And again, you don't have to do that. You have this pair, you have the y-intercept, and make it look better from here. We have 0 comma 1. Okay, as the y-intercept. So you have this pair and this pair, connect them and you're done. Find the equation of a line given 2 points. Find an equation of a line L containing the point negative 1 comma 4 and 3 comma negative 1. Graph the line. Again, I'm giving you the formulas for the slope and the point slope. So first and foremost, we're going to use this formula to find the slope. So y sub 2 minus y sub 1 minus 1 minus 4 over x sub 2 minus x sub 1. Okay. So 3 minus negative 1. This makes it plus 1. So the numerator is negative 5. So negative 5 over 4. You can put the negative in front of a fraction bar in the numerator, in the denominator. Normally, you don't put it in the denominator unless we want to come up with the next point and so forth and discuss the rise and run. So y minus y1 equals m times x minus x sub 1. And we are going to use one of these two points. If we use this one, y minus 4 equals m minus 5/4 x minus minus 1, which means plus 1. And if we distribute, we get minus 5/4 x minus 5/4. If we move the negative 4, becomes positive 4. Because we want to add it to negative 5/4, we're going to change the 4 to 16 over 4. And we get this. Minus 5/4 plus 11/4. And by the way, you should recognize right from here that you do have this y-intercept. However, you can graph, and I highly recommend you find all the intercepts. X is 0, find y, y is 0, find x. So if you plot those pairs, for example, here's negative 1, 4, right? Negative 1, 4. And here's 3, negative 1. And now if you connect them, sometimes we just put a line like that, sometimes in double arrows. meaning it continues indefinitely. It has the same meaning. Find a slope, m and y-intercept b of this equation and graph it. Well, that means put it into the form of y equals mx plus b. That means solve for y. We are going to move the 3x. And we're going to divide everything by -2, and we get y equals 3 halves x minus 3. As you can see, the slope is 3 halves. Here's the y-intercept. And I want to explain, this is b. The y-intercept really should be written in the form of a pair, 0, comma, -3. And I can't emphasize this enough. Okay, so that's the location, everybody. Now, of course, I can get the x-intercept, and it's easier to get it from here, for example, just for the sake of argument, so you see how that works. If you set y equal to 0, then 3x becomes 6, x becomes 2, and the pair is 2, comma 0. Okay. If you were to use this concept of a rise over run, you can write m is 3 halves. So add the bottom, which is 2 to x, the top, which is 3 to y, and it gives you, it happened to give you the x-intercept. It may not. So 3 up, 2 over, that gives you the 2, 0. Connect the 2, and you're done. All right, let's graph lines written in general standard form using intercepts. Here's the standard form: ax plus by equals c, where a, b, and c are real numbers. A and b are not both 0. One of them can be 0. So we want to graph the linear equation that we have here, 3x plus 2y equals 6, by finding intercepts. So you set x equal to 0, you find y. You set y equal to 0, you find x. When y is 0, it's called the x-intercept. 3x equals 6. Divide by 3, you get 2. And it means the x-intercept has coordinates 2, comma 0. Now, if you set x equal to 0, 2y equals 6, y becomes 3, and that means the y-intercept is 0, comma 3. I highly recommend you get to the habit of writing as a pair. And now all you have to do, connect these 2 points, and that's your line. Parallel and perpendicular lines. Two non-vertical lines are parallel if and only if they have equal slopes and different y-intercepts. And let's quickly look at the proof. If two lines are parallel, the right triangle created are similar because they have two equal angles. This angle is equal to this angle. This is 90 degrees, which makes the third angle equal, by the way, as well. Therefore, the ratio of the corresponding sides are equal. That's the definition of a similar figures. Okay, that's the definition of a similar figures in general. And I hope everybody remembers that from before. In any event, and so if that is the case, then the ratio, if they are similar, the ratio of rise to run for this one and the ratio of rise to run to this one must be identical as a result of being similar. And so therefore, if we call m sub 1 as the slope for one, m sub 2 for the other one, they must be identical, but they can't have equal intercepts, y-intercepts, because if the y-intercepts are the same, then of course it's the same line. Okay, if both of these are equal, it's the same line. All right, we are going to move on to perpendicular lines. Two non-vertical lines are perpendicular if and only if their slopes m sub 1 and m sub 2 are negative reciprocal of each other. We can write in the following manner. M sub 2 is negative 1 over m sub 1, or m sub 1 times m sub 2 is negative 1. They make a 90-degree angle at the point of intersection. So I hope everybody's fine with that, and it should make sense to everybody. Okay. Sounds good. We are going to move on, everybody. So m sub 2 is negative 1 over m sub 1. There are different ways of writing m, okay? Their product is negative 1. One is the negative reciprocal of the other. However you like that, it's fine, as long as we can get to one of those. It's good enough. A quick proof of that. Okay, let us choose the lines such that they intersect at the origin. We do it on purpose. And pick a point on each line with the same x coordinate. So if I draw a vertical line, this point and this point must have the same x coordinate. I hope you recognize that. Okay, everybody? Okay. So with that being the case, let me just erase it. So we choose that, let me erase it, didn't get erased. We choose that so that they intersect at the origin. They have the same x coordinate. And let's choose x to be any number you want. You can put 1, 2, 5, 3, but 1 is the easiest one. You can choose anything you want for 1 for this. But if you choose 1, the y coordinates of these points, it has some y coordinates, become equal to their corresponding slopes. Why is that? Take a look. We define m as y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So, for example, if you do it for this one or for this one, okay, this one, m sub 1 minus 0, 1 minus 0 becomes m sub 1. So I hope you see that, how this thing works out, okay? So it's pretty straightforward, everybody. Okay, for one line, you can show it for the other one. Now, if this is a 90-degree angle, Pythagorean theorem says a squared plus b squared equals c squared. So OA squared plus OB squared equals AB squared. And we use the distance formula. Which means OA squared, if I want this one, m sub 2 minus 0 quantity squared plus 1 minus 0 quantity squared. If I want OB, 1 minus 0 quantity squared plus m sub 1 minus 0 quantity squared. If I want this distance AB, okay, I have 1 minus 1 quantity squared plus m sub 2 minus m sub 1 quantity squared. All of them under the square root, everybody. All of them under the square root. However, the reason we won't write the square root, because we are squaring both sides. It makes it easier, okay? It makes it easier. So we use the distance formula, and that should take care of the business here. So let's see what happens next. We are going to simplify each side. This is 1 squared, this is m2 squared, this is 1 squared, this is m1 squared, this goes away, 0. Then a minus b quantity squared, a minus b, I write it here for you. I hope you remember that. It's a squared minus 2ab plus b squared. Therefore, this one is m2 squared minus 2m, m2 m1 or m1 m2 plus m1 squared. Okay, so I hope everybody understands what I'm trying to say here, because it has got to do with what? Knowing perfect square trinomials. Okay. So what happens now? Let's see. I see m2 squared on the left. I see m2 squared up on the right. I see m1 squared on the left. I see m1 squared on the right. And then these two numbers add up to 2 on the left, and the right side is minus 2 m1 m2. Therefore, m sub 2 is minus 1 over m sub 1. Pretty straightforward. So we just proved that. Show the two lines are parallel, perpendicular, or neither. We want to find the relationship between the two. All we have to do is solve for y. To solve for y here, we're going to move the negative 3x. And we're going to divide everything by 2. And so what is the slope? 3 halves. What is the y-intercept? 6, namely 0, 6. For this one, we are going to move 6x, and we're going to divide both sides by negative 4. Y becomes 3 halves x. The slope is 3 halves. Y-intercept is at 0. More precisely, this means 0, 6. This means 0, 0. And they are parallel because these two are identical. The two slopes are identical. Don't have to worry about the graph. They didn't ask, but roughly this is the sketch. Notice the 0, 6 here. Notice the 0, 0 here. The two lines are parallel because they have identical slopes. Find an equation of a line that contains this pair and is parallel to this line. So first and foremost, we have to solve for y to find the slope of this line, which means we are going to move the 3x. Then we're going to divide everything by -4. We get y equals 3/4 x minus 3. This is our slope. So because we want it to be parallel, m1 equals m2 equals 3/4. Y minus y1 equals m times x minus x sub 1. So y minus 3 equals m 3/4 x minus x sub 1. That means x minus minus 1 or x plus 1. So as you can see, this becomes plus 1. And so we have 3/4 x plus 3/4. This moves, becomes plus 3. And we get 3 times 4, 12 plus 3, 15/4. This would be the final answer. Same situation. So those are the two lines in case. Same situation, but we want it to be perpendicular to the same line. So now, if the slope of this line, we show that it's 3/4, the one perpendicular to it is the negative reciprocal of this number, -4/3, everybody, -4/3. And so y minus y1, that means y minus 3 equals m, which is -4/3 times x minus minus 1 or x plus 1. And we're going to simplify it. We're going to distribute. Of course, this is plus 1. So we have -4/3 x minus 4/3 minus 3 moves becomes 3 or 9/3, and it gives us 5/3. By the way, you should always, all of these questions we've been doing, you want to check them, okay? And checking, you can plug in the pair again, it should work. And if you were to graph it, this will look like that. So just in case they didn't ask for the graph. Given A having coordinates -3 and 1, and B having coordinates 5 and 4, find the equation of a perpendicular bisector. I'm going to call it PB for short. L of the line segment AB. I want to define that for everybody and to see what's going on. A line bisector cuts a line segment into two equal parts. In this case, the line segment AB is being cut into two equal lengths by the bisector line L. If the line L crosses at a right angle, it is called the perpendicular bisector. So of AB, otherwise it is simply a bisector. So if you have a line segment, here's the point in between. So if I cut this with any line, it's a bisector. Any line is a bisector. Specifically, when the line makes a 90-degree angle when it cuts it, then we call it perpendicular bisector, okay? That's the concept. Let me clean up the mess. So here's one of them, A having coordinates -3 and 1, B having coordinates 5 and 4. When we connect them, we have to find the midpoint. The midpoint formula is x sub 1 plus x sub 2 divided by 2, y sub 1 plus y sub 2 divided by 2. So add the x's, -3 and 5 divided by 2, add the y's, 1 and 4 divided by 2, so we get 1 and 5 halves. So this is the midpoint between these two lines. So we have this point. What is the slope of this line? If we were to extend this indefinitely on both sides, this would create a line. What would be the slope of this line? Rise over run. Y sub 2 minus y sub 1. That means 4 minus 1 over x sub 2 minus x sub 1. That means 5 minus -3. And that means 3 at top, 5 plus 3, 8 at the bottom. Why do we need the slope of this line? Because the line that is perpendicular bisector makes a 90-degree angle, and the slope for that must be the negative reciprocal of this, -8/3. So PB for short, the perpendicular bisector, has the slope negative reciprocal of that, which is -8/3. Now we have the slope, and we have this pair, and we are coming up with the solution. Y minus y1, that means y minus 5 halves, equals m, that means -8/3, times x minus x sub 1, that means x minus 1. Distribute, you get -8/3 x. Distribute, you get +8/3, and move this, and you make it 5 halves. And all you have to do add up these two. The common denominator is 6. So this becomes 2 times 8, 16. This becomes 3 times 5, 15. They add up to 31. So we have y equals -8/3 x plus 31 over 6. Now 0, 31 over 6 is clear. I'm going to leave it for you to figure out the x-intercept at 31 over 8 actually. So I highly recommend you come up with the answer here, okay? And then if you plot, you can get the line. Needless to say, we already have this point. One more point will do the job, and that would be the line roughly. It may not be to scale, and this is the line AB, equation 3 over 8 times x plus 17 over 8. And this is the perpendicular bisector having this equation. Here's the last question, class. We want to find an equation of a line that contains this pair and is perpendicular to this line. So first and foremost, we are going to solve for y, and we are going to move the x first. Then we are going to divide by 3. Okay, and by the way, that's the point, okay? 1 comma -2. Also this pair, the equation itself, okay, if we continue actually with the line itself, let's actually do that. So let's go back from the get-go. First, let's graph this point, 1 comma -2. I hope you realize if I choose x to be 0, y becomes 2. If I choose y to be 0, x becomes 6. And that's the line. Now we want to find an equation that contains this point, so, and is perpendicular to this, right? So all we have to do, find the slope. The slope for this one Divide by 3 and you get negative 1/3 x plus 2. The slope for the given line is negative 1/3. The one that is perpendicular to that is the negative reciprocal of that, or positive 3. Y minus y1, that means y minus negative 2 or plus 2 equals m 3 times x minus 1. Move the 2 becomes negative 2, so 3x minus 5. I can use that pair to graph it. Also, I can say, well, clearly 0 minus 5 is the y-intercept. And if I set this equal to 0, 5/3 comma 0 is the x-intercept. And I can clearly see 0 minus 5 and 5/3 0 and connect them. And all of those three roughly will be on the same line.